Right, so today we're going to look at an example for the branch and bound algorithm design technique, and the example we're going to look at is called job assignment. So I will first define the premise of this particular problem. We have n jobs and n workers, and we are given with the data about how much each worker charges to perform a particular job. So that's the matrix given here. We have in this example 4 jobs and 4 workers. The number of jobs and number of workers will always be equal, and the matrix represents the charges that each worker asks for in order to perform a specific job. So if you take W2, J1 and the matrix says it is 6, what this means is worker 2 charges 6 units of currency to perform job 1. And if you take W4, J3 equals 9, what it means is worker 4 charges 9 units of currency to perform job 3, and so on. So Ji, Wj is the cost required by the jth worker to perform the ith job. Now our task here is to assign one job to each worker. So you have to do a one-to-one mapping, meaning each worker gets exactly one job. Each job is assigned to exactly one worker. There is no worker who has not been assigned a job. There is no job which has not been assigned to any worker. No two workers get the same job. No two jobs are assigned to the same worker. So basically a 1:1 mapping such that the total charges you have to pay is minimized. So obviously when you allocate worker I to job j, you have to pay a charge equal to matrix of I comma j. So you have to perform an assignment in such a way that this total cost is minimized. So if you take this case where we have 4 jobs and 4 workers, you will see that there are 4 factorial different ways, which is 4 into 3 into 2 into 1, which is 24 possible permutations and combinations of assigning one job to each worker. And of course you can compute the cost for each of those 24 combinations. You can find out which is the minimum, and that's the brute force technique of solving this. But as the number of jobs and workers increases, so let's say you are running some big multinational company or something, you're going to have thousands of tasks and thousands of workers. So then it is obviously not possible to work things out by using the brute force technique, which is why we are going to model this as an optimization problem and look for some smarter technique. So that is where branch and bound comes into place. And if you remember from the previous segments we did on branch and bound, the blueprint or the step-by-step procedure in a branch and bound based algorithm is 1. Define the heuristic function. 2. Model the problem as a state space tree. Start with the initial state and then the first level of intermediate states. At every level, at every state, compute the upper bound if it is a maximization problem, or the lower bound if it is a minimization problem, using the heuristic function you defined, and then you choose whichever state gives you the most promising or the best heuristic value. You will explore that state, you will prune the rest of the state. So that is a recap of how branch and bound works, and we're going to apply that now to this problem.